Today I'm going to go over Math 104, Math Reasoning for Elementary Teachers, a midterm review of 20 math questions. Question number 1. If one must always move upward or to the right in the grid shown, how many paths or ways are there from point A to point B? Before I continue, I just want to give you a quick idea. 20 math questions, if I write those problems on the whiteboard, it's going to take away more than 1 hour. So my way is to reduce the recording and show you everything in less time. I end up typing and having the graphs ready with colors, as you could see. That's going to reduce the recording time. And if you need more details, I will include links to some of those topics because I do have separate videos. For example, this one, I do have a separate video for it. It will be down in the description. Let's get started. Number 1. To go from A to B, before I give you the answer, we need to understand what's going on. So it looks like we could go from A to B as an option this way, going up, 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 right, right, right. That's one option. Or we could go up, right, up, right, up, right. So that's a way to see what's going on, but that's not a good way to count them all. To count them all, we need to use math, because math is all about patterns. Let's take a look. I'm going to change the color or use different colors. I'll use red for up, and I'll use blue for right. The first option that I showed you was up, 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 then right, right, right. The second option was up, right, and up, right. That was the second option. But notice what's going on here. Every single time there are 6 steps. 3 ups or 3 U's and 3 R's. And also notice that this R and this R, for example, they're identical. They're not different, like zip codes. So the first R is not called R1 and the second R is not called R2. They're identical. So if I switch them, it's not going to count another different way. So with that in mind, we call it combination. Need more details? I do have a link down below. What's combination? The formula goes this way. NCR, C for combination. Sometimes we write it C, N, and R. And N here is 6. 6 steps. 3 U's, 3 R's, a total of 6. Looking at R's as an example, putting them in 6 places, that is called combination. With order does not matter. And so focusing on R, we could use R equals 3. I meant capital R. Of course, if you want to focus on U, that's going to be also R equals 3. It doesn't matter. If there is only 1 up and 5 right, I could use R as 1 or 5. Either way, it's going to give you the same answer. Moving on, the formula goes this way. N factorial divided by N minus R factorial multiplied in the denominator by R factorial. So for our problem, it's C6, 3. 3 will be referring to looking at those 3 R's in different places out of 6 places. That will equal to 6 factorial over 6 minus 3 factorial multiplied by R factorial, but that's 3. We don't need a calculator for this. Usually we reach out to the calculator after we simplify some numbers because that's kind of lengthy to type. Meaning the following. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 6 minus 3 factorial, that's this one right here. That is the same as 3 factorial, which is 3 times 2 times 1. And this right here is 3 factorial, which is 3 times 2 times 1. And this is what I meant by reducing our numbers before we reach to the calculator. I could cancel 3 times 2 times 1 with the 3 times 2 times 1 on top. I could also look at 3 times 2 times 1 down below as a 6. That's a 6. Cancel it with this 6. The only numbers left for me on top, 5 times 4, and down it's 1. So 5 times 4 over 1, which is 20. So the answer to the question is 20 different ways from A to B with the conditions going up or right. That should do it for number 1. I have 20 questions. So here's number 2. Who am I? If you multiply me by 12 and add 21, the result is 117. So let's call this x. If you multiply me by 12, so 12 times x and add 21, I get 117. To solve this problem, it's just simple math. We're gonna subtract 21 from both sides, and now I get 12x equals 96. Then I could divide both sides by 12 to leave x alone, and now x equals 96 divided by 12, which is 8. And we could also double check. 8 times 12 plus 21 should give you back 117. Next problem. Find the number of terms in the following arithmetic progression. Now, since it says arithmetic, we need to use the arithmetic formula. It's not a good way to answer the question by listing all the numbers and start counting them one by one. I had sometimes students do that, but that doesn't count, because what's the point of the problem if I say how many numbers are there using the arithmetic as a underlined word under that concept, and you just count them by hand? What about if the last number is 3? It's not 388, it's in the thousands. Are you going to list them all? Of course not. So what do we mean by the arithmetic? The arithmetic is the following. Arithmetic sequence. An arithmetic sequence is a sequence that has the property that the difference between any two consecutive terms is a constant. This constant is called the common difference D. The explicit formula, there's another formula, but let's focus on one formula and reduce that time for recording. The explicit formula for the arithmetic sequence, given the first term as A1 and the common difference as D, will be written on the right hand side, right here. So the first term is A1 and the common difference is called D. D is the common difference. Notice from -4 to 3, we're adding 7. From 3 to 10, we're adding 7. From 10 to 17, we're adding 7. So that's a fixed difference, and we call it common difference. That's a plus 7. So that is the concept that we have here. So here we go. So we agree that D is 7. That's called the common difference. 17 minus 10 is 7. 10 minus 3 is 7, and so on. That is plus 7. So D is 7. And of course, A1, the first term, that's -4. The concept is clear. A sub n, the nth term, is A1 plus n minus 1 multiplied by D. That many D's, you count them. To go to the 17 from the first term, you're adding, that's the fourth term. 17 is the fourth term, as you could see, but we're adding how many D's? 3 D's. It's kind of like a difference or steps that takes you there. That's the reason why it's n minus 1. Okay, now, A sub n equals A sub 1, which is -4, times plus 7 for D, and number of terms is missing. So we're going to write n minus 1. And I could write also and save steps. Instead of A sub n, the last term for us is 388. Solve this and we're done finding n. We're going to add 4 to both sides. This cancels. And I have 392 equals 7 times n minus 1. Then I'm going to divide by 7, trying to reach out to the n minus 1 or n. This cancels. And 392 divided by 7 is 56 equals n minus 1. Let's add 1 to both sides. And now we end up with n equals 57. So the answer to the question, we do have 57 terms. And I don't think it's a right way to list them all and count them. Imagine if you list them all and you miscount and you write the answer as 56. That's not the right way. Just a quick concept. Number 4. Find the rule to used to change one number into another. Like the rule of this table, like the number chosen is 3 or 4 or 5 or 6 or 7. The number given back is 11, 18, and so on. What's the rule? Well, we have to show you something here. At first, 3, 4, 5, 6, 7, that's a good way to start. We're not missing anything, and they're not jumping around. They're not going 3 to 4, then 11, then back to 5, you know, so and so on. Meaning, if you have a fixed difference here, going by 1, then you could use this concept. Find the difference right here. If the difference is constant, that's going to be linear function, and that constant is actually the slope. But let's take a look. 11 to 18, we're adding 7. 18 to 27, that's not 7 anymore, it's 9. 27 to 38, that's 11. And 38 to 51, that's 13. Next, let's do it again. Let's change colors here to stay focused. Notice from 7 to 9, that's 2. From 9 to 11, that's 2. From 11 to 13, that's 2. Once you have the second fixed constant, we are looking at second degree. Second degree function. Now, to see what's going on, we're thinking second degree because we do want to build like a system of equations and solve. We'll just make it with analyzing, let's say, and quick guess and check. 3 second degree square it, that's 9. 4 square it, that's what? 16. 5 square it, that's 25. 6 square it, that's 36. And 7 square it, that's 49. But notice from 9 to 11, you add 2. So you need to adjust them by 2, as you could see. So the answer is the general rule. If this is n, this is a sub n. A sub n will be, you start with n, you square it, and adjust it by adding 2. That is the rule that we're looking for. Next. Number 5. Find the 36th term in the number sequence that corresponds to this dot sequence. Sometimes students, when they see dot sequence like this, they go like, where do I start? Well, it's the same thing like last problem, but it's not within a table. What do I mean by this? This is the first when n equals 1, second, 3, and 4, and so on. We're looking at when we go up to 36. Find the 36th term in the number sequence that corresponds to this dot sequence. In other words, how many dots are here? That is the question. Well, to look at the answers right here, to start analyzing, we have 2 dots here, we have 5 dots here, we have 8 dots here, and we have 11 dots here. You could count them as like 9 plus 2, that's 11. But we don't want to count them this way, like 2, 5, 8, 11. Notice the graph is showing me a pattern. To go from the first to the second, we are adding what? 3. Then we're adding another 3. Then we're adding another 3. Which is clear that we are adding 3s. So you kind of like have a table now, and you're looking for the difference. If the difference is fixed from the first time, we call it linear, and that is the slope. So, one more time, the focus is 1, 2, 3, 4, and the numbers are 2, we have 5, 8, 11. The common difference, if you want to use the arithmetic sequence, is 3. So we could use a sub 1 equals 1, and we could use d equals 3, and we need a sub 36 equals question mark. So a lot of different ways you could solve problems like that. I'm using arithmetic. You could use slope, intercept formula, and so on. To organize our numbers, one more time, we had 2 here, we had 5, 8, 11, and all the way we need to find this much. To stick with the arithmetic, I do have a sub n equals a sub 1 plus d multiplied by m minus 1. 36 equals, or a 36, a sub 1, which is 2, d is 3, and n is 36 minus 1. Equals 2 plus 3 multiplied by 36 minus 1, which is 35. we follow the order of operations inside parentheses, grouping symbols first, equals 2 plus 3 times 35, 105, 2 plus 105, 107. So the answer is 107. Find the 36th term. The 36th term is 107. That should do it for number 5. Number 6. An average newspaper contains at least 16 pages and at most 87 pages. How many newspapers, just called N, must be collected to be certain that at least 2 newspapers have the same number of pages? Like you pick 2 and they end up both with 18 pages. That's the meaning. Of course, when you pick 2, you might get lucky, but that's not what we're looking for. To be certain is the main word. To guarantee, to be certain. The pigeonhole principle on the right side. One more time, I'll have a link for more detailed examples down below for the pigeonhole principle. But in this review, I'll try to make it short as much as I can. The pigeonhole principle formula says n equals m multiplied by k minus 1 plus 1 outside the parentheses. N will refer to the pigeons and m will refer to the holes. Notice I'm using different colors. This right here is this number k. Because sometimes they don't ask you about at least 2, they ask you about at least 3 and at least 4 and so on. So you will be focused or forced to use this formula. Let me show you more ideas. So that's in short. Just focus on this k as 2, where how many newspapers you need to pick to be certain. That is the number of pigeons. Why they call it pigeons and holes? Here's another quick concept why it's called pigeons and holes. We have the pigeons right here in the figure and the holes, which shows 9 holes in the figure. So n is, in this case, is 10. Why? Take a look at this. I do have 2 right here. So 9 plus 1 is 10. So that is 10 pigeons. And we could clearly see that it's 9 holes. Since 10 is greater than 9, the pigeonhole principle says that at least one hole has more than one pigeon. Because you do have more than the number of holes. If you have 9 pigeons and 9 holes, and if you could force them all to go in one place, one hole, yeah, maybe. But you're not going to be certain to have that 9 in just one hole. To be certain you're trying to avoid it, put 1 in each hole, but you're going to be forced to have, as you could see, forced to be certain. To have one more. Number of pigeons will be more than number of holes. That's a start of the concept. And at least 2 is another way to see it. At least 2 is another way to look at it. Okay, now making sure that we are on the right page, that I'm not going away off. Okay, this is my slide that I'm going to be working on. An average newspaper contains at least 16 pages and at most 87 pages. That will refer to the number of holes. That's in red. To count them, you don't want to count them by hand, like 16, 17, 18, 19, and the maximum was 87, and start counting them. We have another way to count them, and here's one way to do it. Take a look. So we have, let's say the number of pages are instead of this, we say 5 minimum and 8 maximum. So how many holes do we have here? We have 1, 2, 3, 4. But if you go 8 minus 5, that's a 3. We need to add 1. So 3 plus 1 makes it 4. That's 4 holes. Going back to the problem, let's take this off. And you could double check. What I'm trying to say is 87 minus 16 plus 1 will give me the total number of pages for newspapers. And that is 71 plus 1, which is 72. So that's 72 different number of pages we have. If I pick the worst case scenario, if I pick 72 newspapers, I'm not going to be certain to have this happen. Why? Because the first one could be 16, the second one could be 17 pages, the third one could be 18 pages, and the last one, the 72, will be 87 pages. To be certain, I need one more. And that's the whole idea. The answer is 73, because we just need to focus on this. But let's just do it with the formula. Here we go. I have n equals m times k minus 1 plus 1. 73 take this back. N equals m, number of holes, we said 72. You could count them and take your time, double check that this is true. That's the number of holes or possible different newspapers that I could have, times at least 2, so k is 2, minus 1, which is not gonna make a difference right here, but if it's not at least 2, you're gonna have to use that number, plus 1. 72 times 2 minus 1 is 1. 72 times 1 is 72, plus 1, 73, and that is the answer. So using the formula, n will be 73. You need one more than 72 newspapers to guarantee that you will have at least 2 of the same number of pages. Okay, I think that should do it for number 6. As I said, I'll add a link down below for more details and more examples. Number 7, how many posts does it take to support a straight fence that's 140 feet long if the posts are placed every 10 feet? To do that, it's not a proper way to make a line of 140 feet and start putting the posts. So we need to think about a system. Here's a quick example. For example, if the fence is only 50 feet long, that means I do have 10, 20, 30, 40, 50. As you can see, I'm trying to show you the concept. And if you look at a post right here, and 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 a post right here, we end up with how many? 1, 2, 3, 4, 5, 6. So how do I count them without doing this? If it's not 50, it's like 140. I'm not gonna draw a line and make it 10 increments and start counting. But notice that these numbers, there are 5 of them. So 50 has 5 tens. And by 5 tens, I end up with 6 posts. Why? Because we are somehow looking at the ends. Because of the ends, we need to add one more. So that's what we're looking at. 50 will give you 6 posts. 140 divide by 10 to see how many tens we have. That's 14. So how many posts we are gonna end up with? 140. So let's undo that. 140 divide by 10, and we need to add 1 because of the ends, and that's 14 plus 1. 14 plus 1, which is 15 posts. The reason why? Because of the endpoints as I showed you in the examples. Number 8. A pet shop has a total of 15 dogs and birds. Altogether, there are 42 feet. How many dogs are there and how many birds? So, for dogs, let's use D instead of X and Y. For birds, let's use B instead of X and Y also. When you say total 15, that means the number of dogs, where D represents the number of dogs, plus the number of birds, which is B, that should be 15. But if D is 3, that means we have 3 dogs, and every dog has 4 feet. 3 times 4, that's 12. So looking at the number of feet, we have another equation, which is 4D plus for birds, we have 2. That should add up to 42 feet. So half of the work is done, because if you cannot write the system, you cannot move on. Writing the system, depending on what is given, is essential. Then you start solving using algebra. You could do it a lot of different ways, substitution, elimination, but I'm gonna do the following. I'm gonna multiply the first equation by -2. You'll see that in just a minute why. -2D minus 2B equals -30. Second equation as is, 4D plus 2B equals 42. And notice if I add these two equations, it's called elimination method. What happens here? B cancels. So I was looking at this right here. If I could have the same amounts but opposite signs and add the two equations, it will cancel. This way I could solve for D first, then I go back to B. And if you're going to cancel the D right here, I have to multiply by -4. I think -2 is less, so I picked -2. Okay, moving on. Left-hand side is -2D plus 4D, or 4D take away 2D, that's 2D. 2D equals 42 took away 30, that's 12. Divide both sides by 2. And now we have D equals 6. We're almost done. We have D. So we could go back and use either equation, doesn't matter which one. I'll use this one. If this is 6, 6 plus what as mental math equals 15. That should be 5. So we have D plus B equals 15. 6 plus B equals 15. If you want to write the steps, subtract 6, subtract 6. And I end up with B equals 15 minus 6, which is 9. So we end up with that's a 9. It's right next to it. And D is 6. So I wrote D. 6. So you have 6 dogs and 9 birds, which is a total of 15 dogs and birds. And if you count the number of feet, that's going to be 42 feet. Number 9 is also a lengthy one, but I'm trying to make it quick, as you could see. 8 people come to a party to shake hands with each other. If each person shakes the hand of every other person, how many handshakes are occur? Well, I'm not going to start with one person because he's not going to be able to shake hands. But look at this right here. 2 persons. I'm looking at this right here. 2 persons. That's only 1 handshake. 3 persons. You don't see them. But think about a person here and a person here and a person here. How many handshakes? 1, 2, 3. 4 persons. Call them A, B, C, D. I could see that A has 3 options. He could shake hands with D. He could shake hands with C. He could shake hands with B. So we're getting into some kind of pattern right here. Of course, if I focus on B, B could shake hands with C. B could shake hands with B, D. B could shake hands with A. And the story continues. Now, if you have in the 3rd figure, or the 4th figure right here, 5 persons, A, B, C, D, notice that A could do how many handshakes? 4. So for 5 persons, each person has a total of 4 handshakes. Let's look at this. Let's ignore this because it's the same thing but counting how many in total. I don't want to count them all and confuse you right here. I'll show you in a minute because I'm going to go over it towards the end. Ours is 8 people. That's 8. A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, and that is our graph. As I said earlier, focusing on one person, let's say A, and if you want to count how many handshakes, it's not going to be 8 because he can't shake hands by himself. It says every other person. So it's going to end up 7. A will have 7 different handshakes. Let's count them. 1, 2, 3, 4, 5, 6, 7. But when you move to G, G will have 7 also. But notice that you cannot count GA anymore. Why? Because AG was counted. So the concept is now simple. Hopefully it's simple. When we have 8, when we have a number n, each one of them could shake hands n-1 times. For 8, we have 7 times, as we could see, for A, for each one. But because we're double counting like AG is the same thing as GA, we're going to have to divide by 2. And that is the formula. So 8 divided by, multiplied by 8 minus 1 over 2 will be 8 times 7 over 2. We could reduce between 8 and 2, divide by 2, 1, divide by 2, 4. 4 times 7 is, okay, one more time. That's going to be 4 times 7, which is 28 different ways. So the answer is 28 different ways. Let's see why. Let's highlight that as our final answer. Now, what's interesting in math, these are called triangular numbers. And this is Pascal triangle. 0 persons, 1 person or row number 1, row number 2, if you count the first one as row 0. Row number 3, row number 4, row number 5, 6, 7, 8. 8 persons, we are in row 8. The answer is 28. These numbers are called triangular numbers. I do have a special video about triangular numbers, but I think for this problem it's fair enough. And I do have a link for the number of handshakes down below. I will list the link down below. Fair enough for number 9. Let's move on. We're almost halfway. Number 10. To get a B in math, Alexandria must average at least 80. At least 80 on her tests. Scores on the first 4 on her tests. Scores on the first 4 tests were 80, 73, 83, and 74. What is the lowest score that she can get on the last test and still get a B? To do it, we're gonna do the following. I do have 80 plus 73 plus 83 plus 74 plus, we don't know the last one. To get a B, Alexandria must average at least. What is the lowest score that she can get on the last test coming? So let's call it X. Now the average for these exams, you add them up and divide by how many? So we have 1, 2, 3, 4, 5 total. So I'm going to divide by 5. At least 80, an average, that means greater than or equal to 80. Of course, if she gets 81, 82, she will get the B. To finish it, adding 80 plus 73 plus 83 plus 74, I have the math as 310 to save you some time, plus X over 5 greater than or equal to 80. We could multiply both sides by 5 over 1, and when you multiply by 5 over 1, which is positive, the inequality symbol stays the same and this number cancels. So I end up with 310 on the left plus X greater than or equal to 5 times 80, which is 400. Subtract 310 from both sides. That will keep the inequality the same. We end up with X, which is the score for the last exam or the coming exam, should be greater than or equal to 90. So what is the lowest score that she can get on the last test and still get a B? The lowest score is 90. That is the lowest score. She has to score 90 or higher. Number 11. This is a Venn diagram. You could do this also different ways, but let's try our best to make it quick. Let U, which is the universe, equals Q, R, S, T, U, V, W, X, Y, Z. We don't want to start with U which is the universe, but we're going to start somewhere else. That's the best way to do it. We have A and B and C listed. List the elements in the following set. C complement intersect A complement. To get started, going back and forth between A and B and C, notice that A and B and C, they have the Y. That's the only thing in common. So I'm going to write the Y where it should be. Now, going back and forth, I could see that Z is listed between C and B. Between C and B, so I'm going to write Z. So the concept here with Venn diagrams like this one here, you want to start from inside out. Looking at A and B, we could notice the following, that A and B, they have Q in common and they have S in common. So I'm going to write here Q and S. Between A and C, we could see that we have W in common. So I'm going to write W right here. Now, what's in A that was not mentioned at all is this right here, this U. So that's going to go right there. So let's write it down in black maybe. You can double check that A is Q, S, U, W, Y, and that shows on the circle. B is all mentioned. As you can see, everything's underlined. C, I could see that in C, I have two things are not mentioned. The X and the V. The X and the V will go right here. So, one more time. Let's use black and write X and V. Now, going back to the U part, everything is mentioned except R and T. We talked about everything else, the Q and S and T, U, sorry, not T. Let's circle them or point to them. This right here, R and T were not used at all. They're not stated in either A or B or C. Anything else was mentioned. Q was mentioned right here. S was mentioned some places. U was maybe right here. V was right here. W mentioned. X mentioned. Y and Z. You could see it different places. So we have T and R outside the sets A and B and C. C complement intersect A complement will be everything outside C and at the same time outside A. Clearly, outside C and outside A at the same time will be just T and R. So that should be T and R. Let's say you don't want to do the Venn diagram and you want to do it a different way. Here's another option. So we could use the following. We know that C equals V, W, X, Y, and Z. So C complement will be everything outside that. So to do that, we have U, Q, S, R, and T. That's everything but not C. A complement, if you take your time, trying to go a little bit quick but show you more concepts, everything outside A. So looking at A right here, Q, S, U, W, Y, and looking at U right here, you want to look at everything here but not these elements. And that will be X is not in A, V, Z, R, and T. Now, C complement intersect. A complement will be the intersection between these two sets, and that is clearly R and T. Same answer. I think that should do it for 11. Let's move on. Number 12. The number of elements in A is 32, the number of elements in B is 93, and the number of elements in the union is 109. We need to find the number of elements in the intersection. This is not meant for Venn diagram. We have the formulas on the right side to use, but I have the Venn diagram for a reason. And I see students sometimes for the number of elements in A, 32, they write 32 inside. And the number of elements of B, they write 93. That's not true. The way we write the 32 and 93 is the following. 32 should be up here for the whole circle, and 93 should be up here for the other circle titled with B. The union is 109, and that is the union. The union is the two sets combined without repeating the intersection. That should be 109. To solve for the intersection, we could use this formula, but since the intersection is on the right side, we could move it to the left, move the union to the right, and that becomes the second formula right underneath. So we do have the intersection by itself on the left, and let's get started. N of A equals 32. N of B is 93. The union is 109. Adding 32 to 93, that's 125 minus 109, and the answer is 16. So for this problem, the answer is 16. Let's double check. If this is 16, the number of elements in A is 32. 16 are already taken for the intersection between A and B, so that should be also 16. 93 for B, but 16 already counted for to be in the portion of A, so the difference will be 77. Let's double check. 16 and 16 and 77. 6 and 6, 12. 12 and 7, 19. 7, 8, 9, 10. 109 is the union. So the way to solve for the intersection or the union, given what you're given right here, is using the formula on the right side. This is the formula, not the Venn diagram. And that should do it for this problem. Number 13. Determine if the given set of a whole number of whole numbers, just 2, 8, and 9, is closed under addition. Well, we have to stick to these two words. Under addition, it's not going to be closed. The answer is no. Why? Because, for example, which is in math called counterexample, take 2 and 8 and add them up. 2 plus 8 is 10. 10 does not belong to A if I call the set A. So it's not closed. Closed means under the given condition, operation, which is addition in this case, every time you pick on any two numbers and you add, you stay inside. You don't go outside of the set. That's the meaning of closed. Okay? I could give you more examples, but I think it's enough because I do have other problems. So closed means under the given operation, you don't go out of it. You stay inside. Number 14. Rewrite the following in the form of a single exponential. So we need to write this as something like that. Just single base. Give you an idea. The power of product rule of exponents says A times B all together to the power n. We could apply the exponent n to A and to B and do it. Let me show you quickly why this is true. For example, P times Q to the power 3, that means multiplying PQ by itself 3 times, 3 factors. Rearranging, I could have P in the front, Q at the end, and you end up with P to the third, Q to the third. So this is true. Now, that's the formula. But writing it the other way around, that is this right here. And that's what I'm going to use for my problem. So I'm using it backwards. Meaning, that is like 6 to the power 6 multiplied by 2 to the power 6. So notice that n is the same. So we're going to keep it up there. Equals, my A is 6, my B is 2, and my n is 6. So the answer is 12 to the power 6, and we are done. That's it. That's a quick one. Number 15. Convert to base 10. To convert to base 10, we need to understand the concept of bases. In base 10, we have units, tens, hundreds, and so on. The hundreds means 10 to the second. The tens is 10 to the first, and so on. That's the values of bases. In this case, this means 4 times plus 3 times plus 6 times. Since we are in base 8, that's going to be units value. That's going to be 8 to the first. That's going to be 8 to the second. Just like in base 10. So if this is in base 10, that's going to be 4. Let's say in base 10, that's going to be 4 times 10 to the second plus 4 times 10 to the first plus 4 times 10 to the 0. Units, tens, hundreds. But we are in base 8. So that's the value of each number. This 4 is 4 times 8 to the second. Like how many 64s do you have? Not like how many hundreds do you have. Okay, let's finish it. We're almost done. Equals 4 times 3 times 6 times 64, 8, and 1. Four times 64 is 256. 3 times 8 is 24. 6 times 1 is 6. We could add either way we want, but the numbers add nicely. For example, 6 and 24 is 30. So we have 256 and 30 more. And that is 286. In base 10. Just to confirm that we're in base 10. Okay, that's another quick one. Number 16. Perform the indicated operation, being careful not to leave more than 59 seconds or 59 minutes in your answers. In other words, when you subtract right here or add, we don't want to write like 117 seconds. That doesn't make sense. That should be grouped, and because it has more than 1 minute. That's the meaning. All right. So to get started, we can't subtract 29 minus 57. But we can do what? Go and borrow 1 minute from 57 minutes. That becomes 56 minutes. Now adding 1 minute to 29 minutes, but 1 minute is 60 seconds. So when you borrow 1 here, 1 minute, that is gonna be written as 60 seconds on top of 29 seconds, which means now what do I have? I do have 29 plus 60 . 29 plus 60 is 89. So we're going to have 89 seconds. Now 89 seconds minus 57 seconds. 89 minus 57. 9 minus 7 is 2. 8 minus 5 is 3. So we have 32 seconds. Going to the left, let's go with blue. 56 minutes minus 39 minutes. 39, 40, 40 to 56, 16, and 117. So we could do it quickly, and we could write that is 17 minutes. 9 hours minus 3 hours, we didn't have to borrow or touch it, 6 hours. So what's the final answer? The final answer is 6 hours, 17 minutes, and 32 seconds. That's the final answer. Number 17. Find the difference in base 4 notation. To subtract in base 4, I need to give you some kind of introduction. We're not going to be able to do it so quick. You're not going to follow me by going like, what's going on here? 2 minus 3, we can't subtract. We have to borrow 1 from 3, but we are in base 4. So we need to understand how to count in base 4 and what's the meaning of base 4 values. In base 10, for example, we know how to count because we're used to it. 0, 1, 2, up to 9. Notice after 9, we say that this place value is filled. That's the maximum that we could have. In base 10, we go from 0 to 9, which is 10 numbers. But after 9, we have to force it to be 0, and we open another digit to the left, and we call it 1. Then after that, we add 1 to the 0, and add 1 to the 1, 1 to the 2, and we just keep going. After 19, 9 is filled. So we force it to be 0, we add 1 on top of the other one on the left, make it 20. So in base 4, how do we count? In base 4, we only have the numbers 0, 1, 2, 3. I see some students, sometimes they write the answer. Since we are in base 4, they write 5. Somewhere here, like, and there is a 5. There is no 5 in base 4. Just make sure that you go up to 3 only. Just make sure. Series is 5 out of the way. So let's go back and count. 0, 1, 2, 3. 3 is the max, so it's filled. To add one more to it, I have to force it to be 0 and add 1 to the left, just like in base 10. Then after that, I keep adding to the right side the units place till it's filled. Now it's filled again. I'll force it to be 0 and I'll add 1 to the left, so it's going to be 2, 0. Sometimes we say 20 by mistake, but it's not 20 as 20. So 2, 0 means two 4s and 0 units. 2, 1, and the story continues. 2, 1, and the story continues. Let me show you more. Now, everything is filled right here for me and you for the convenience. And we need to focus right here. So I zoomed in only to 23. And let's move on. Now, to subtract in base 4, I need to borrow 1 from 3. So I'll make it 2. When I say borrow 1 from 3, I'm not borrowing 1 10, I'm borrowing 1 4. But I do have 2 units and 1 4. That's going to give me what? Two units and 1 4. This one right here is 1 4 and 0 units. 2 more will take you down to 12. So I'm going to write 12. Think about it. I do have 2 units. I do have 2 units. But I borrowed 1 4 from 3 4s. So I do have 1 4 and 2 units, which counts as 12. Okay? Now, let's erase this and I'll show you another thing. Now, once you are in 12 and you want to subtract 3, you could go 1, 2, 3 backwards, called subtracting. That's going to give me 3. So what I'm trying to say is you need to know how to count in base 4 to add and subtract. Next, 2 minus 2 is 0. We don't need to write it down. So the final answer is 32 base 4 minus 23 base 4 is actually 3 base 4. And that should do it. I think it doesn't hurt. Let's double check. Let me show you. If I add this to this, do I get this? You know, in math, when you go like 7, in our systems, if you go 7 minus 2 equals 5, to double check, you add 5 plus 2, and you get 7, right? That's what I'm trying to show you. So, by doing that, if I add 3 base 4 to 23 or 23, not 23, do I get this right here? Let's double check. 3 and 3 is 6. 6 is 12 in base 4. Or 3 and 3, 1, 2, 3. So 2, we carry the 1. 1 and 2 is 3 in base 4. We're not outside of our system 0, 1, 2, 3. And that should do it. It's what we want. So adding and subtracting to confirm gives you more practice and more skills. Number 18. This is going to be a quick one. David's company has to ship 2,658 boxes of sprinklers. If a truck can hold only, or max, 550 boxes, how many trucks do you need? Well, thinking about the concept, every truck, let's call this as a truck, holds 550. And I'm going to add another truck, but that's not enough. So let's see if you keep doing this, that's by try and error to see how many boxes. But to do it in less time, we're going to divide 2658 by 550 to see how many 550s in it. And if you do the math, that is going to end up 4.8327 and 27 repeating. So if I keep adding 550 and 550 and 550 and 550 4 times, that's not going to give me a total of 2,658. We need the extra ones to go in another one. Let me show you what I mean. So 550 plus 550 plus 550 plus 550, that's this 4 right here. Plus the extra ones will be 458. I did the math on the side to show you that that will end up 2658. So that's one truck, that's another truck, 3, 4 trucks, but I need the 5th truck because you can't just like have a fraction of a truck. So how many trucks are needed? 5. 5 trucks are needed. Okay, that should do it. Number 19 and 20, we're almost there. Multiply in base 5. To multiply in base 5, you need to know how to count in base 5. Same idea, same concept. Let me show you. When you use base 5, we're using 0, 1, 2, 3, 4. We can't use 5. Those are 5 numbers. Maximum number 4. Once you get to 4, just like in base 10, it's filled. We force it to be 0 and we open 1 to the left. It looks like 10 to us. When we get to 14, 4 is the max. It's filled. We force it to be 0 and we add 1 to the 1 on the left. We make it look like 20 and so on. Now when you multiply, since we are multiplying here, as you can see, let's go 4 times 4. 4 times 4 is 16. 4 times 4 is 16. But 16 in base 5 is actually in base 5. 3. One more time. Let's erase this mark right here. 3 5s and 1 unit. And that is 3 5s and 1 unit. It looks like 31 to us, but it's 3 5s and 1 unit. Here's another thing that we're going to be using. How about 2 times 3? 2 times 3 is 6. 2 times 3 is 6. But 6 is equivalent in base 5 to what? 1 5 and 1 unit. Yeah, that's looks like 11. Now, going back to the problem, we need to multiply 3 times 2, and we just agreed on it to be 11. So I'm going to write 1 right here and carry the 1. Now, 3 times 4 is 22, plus 1, 23. 3 times 4 is 23. 3. So I'm going to write 23. Let's write the numbers again. Now we're going to multiply because we don't need the extra marks. So we're going to start right here. Let's take this number off out of the way. And let's multiply right here. Let's multiply these two. Now we are multiplying 4 times. Sorry. We are multiplying 4 times 2. And then after that, multiplying 4 times 4. Now, 4 times 2 is 8. 4 times 2 is 8. But 8 in base 5 is what? 1, 5, and 3 units. Here's 8. So that's going to be 13. We move 1 place to the left. We write the 3 and we carry the 1. 4 times 4 is 16. And 16 is 31. Which I mentioned earlier, that's 4 times 4 is 31. 16, which is 3 5s and 1 unit. But we need to add the 1 on top. So I'm going to write 32. 32. Then we're going to add them up. 1 goes down. 3 and 3 is 6. But 6 is 1, 5, and 1 unit. We carry the 1. 2 and 2, 4, and 1, 5. But 5 is 1, 5, and 0 units right here. Which is 10, as we could read it 10. 1 on top of the 3. 1 and 3 is 4, and 4 is acceptable. So the answer to this problem is right here. 40. Where do I write it? Let's just highlight it. That's the final answer to the problem. Okay, 4011. I do have separate videos for multiplying different bases. I will link them down below. The last problem, number 20. We multiplied in base 5. Now we're adding base 5, which is pretty much the same concept. You need to know how to count in base 5. And we know how to count in base 10. After 9, we make it 1, 0. After 99, they're both filled. We force the 9s to be zeros and we add 1. So, in base 5, after 4, we write 0, 1, or 1, 0, I mean as a 10. After 14, if you read it 14, 4 is filled, the highest. So we add 1. We force the 4 to be 0, and we add on top 1 on top of 1. Now it looks like 20. After 24, 4 is the highest. Add 1 more, 30. Let's see what is 1 and 4. It's a 5. 5 means 1, 5, and 0 ones. So that is 1 and 4. But we can't write 5 in base 5 because we're using 0, 1, 2, 3, 4. And that should be written as 0, and we carry the 1. Now, Second column, 1 plus 2 is 3, plus 3 is 6. 6 is right here. That means 1 5 and 1 unit. So 1 5 and 1 unit. Next, let's use different color right here. 1 and 2. 1 and 2 and 4. That's 3 and 4, 7. 7 is right here, which is 1 5 and 2 units. We don't want to carry the 1, we'll just write it down here. So the answer is 1 2 1 0 in base 5, of course. Let's use the base 5 in different color. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.